What's up, scholars? Welcome back. Lesson number 2. I'm Ms. Atkin.
And I'm Lisa.
And today we're talking about
distances. So we've learned about different type of distances in school before, but the ones we're going to be talking about today are actually geometric. So we've learned about distances in school before, but the type of distance we're going to be talking about today is So we've learned about different types of distances in school before, but the one we're going to be talking about today are actually geometric distances. So we're going to go through 2 examples. Our first one will be adding 2 segments together.
1.
So let's say we have a tightrope walker, and she knows how long she has to walk from point A to C. So that distance is actually 12 feet, but the circus ran out of funds, so she could only get a net from points B to C for what is 9 feet. So she's up in the air right now, and she's like, I don't know how long I have to walk from A to B. So the way that we're going to do this is we know that from that A to B plus B to C will equal to 12 feet. So in order for us to find that missing length, we can do the known length minus the 9 feet and get our AB. Or as Ms. Atkin wrote it, like that. And then you would just solve for point AB, and you would get 3 feet. So for our second example, let's say we have a segment, MP, but you have a whole bunch of little segments in between. So the way that you're going to want to find this full length is adding every little segment that is within this big segment. So you would do MN plus NO plus OP to equal MP. What I always find useful is you could always draw in the values that you are given for the certain segment. So for example, for NO, you're given 5. You can just write that value in so you kind of remember that. Then you just work your way in. You can fill it into the equation Ms. Atkin wrote below, and you will get your final value of MP. As you can see, Ms. Atkin wrote these kind of like bracket looking things. I always find those useful. They kind of help you with the addition. You can just work through it easily. And yeah, I hope that helps. So Ms. Atkin is now just writing in the values that she got from the different addition postulates, and our final answer will be 18. All right, so now we're going to talk about midpoints. So we have Donnie for D and Catherine for C. So they actually want to hang out, not during quarantine though, but they realize they want to go the same amount of distance, so they want to spend the same amount of gas money. So in order for them to find that midpoint, we're going to think about their coordinates as the averages between the x's and the y's. So the way we're going to do that is first, we're writing Catherine's coordinates and then Donnie's. So the way we'll find these averages or midpoints, we'll do midpoint equals x1 plus x2 over 2. And then we will do the same thing for y, being y1 plus y2 over 2. So we can think for Donnie, we can use x1 and y1, and then for Catherine, we'll use x2 and y2.
Go.
So we have plugged in our numbers for the midpoint. We have -3 plus 7 over 2 and y plus -7 over 2. So once we solve for this, we will get the coordinates or midpoint at which Donnie and Catherine will have to meet in order to spend the same amount of gas. We will get 2, -3 once we solve for our coordinates.
1.
Ok, chicos, entonces ahora vamos a aprender del teorema de Pitágoras. No, guys, I'm just kidding. So the last type of geometric distance that we're going to talk about is the Pythagorean theorem. So a lot of us learned this in middle school, but just a little reminder, the equation for this theorem is a squared plus b squared equals c squared. One key thing that we must remember for the theorem is that it can only be used with right triangles. You can't use this with an obtuse, acute, etc. And always remember as well that your C side will always be across from the right triangle. And another term that you can use for C is your hypotenuse. All right, so let's suppose that for our example, we are actually building something. So we know that side C is 20 feet long, side B is 15 feet long, but in order for this to be squared or a right triangle, how long must side A be? So the first thing we'll want to do is plug in our numbers into our Pythagorean theorem. So we do a squared plus 15 squared is equal to 20 squared. So first thing we're going to want to do is square our 15 and our 20, which we will then get 225 and 400. So we want to get x squared by itself on the left side. So we will want to subtract 225 from both sides. We will then get x squared is equal to 175. So now we have x squared equals 175. Always, always, always remember to square both sides so that you can get x by itself. Now you have x is equal to the square root of 175. So we will want to do this one of two ways. First thing we'll want to do is break down this square root. So the way you will do that, you can find the factors, any possible factor for these two numbers. In this case, we will be using 5 and 35. You will then want to break down 35 to be 5 and 7. And then you realize that you can no longer break down any of these three numbers, but you do have one common number, which is 5. You have a pair. So your final answer will be x is equal to 5 radical 7. The other way we will want to write this is we could do square root of 175 as a decimal. Remember to always round to the hundreds, or well, whichever the example says to round in. And for this case, we will do 13.23. So a quickly review over what we learned today. So we went over geometric distances. The first type we did was segment addition. Always remember you will want to add the smaller segments between the big segment to find that final answer. We then went on to learn about our midpoint. So you can always think about this as sort of an average. Always remember to do midpoint is equal x1 plus x2 over 2 and y1 plus y2 over 2 to get your final answer, and you will then get that coordinate for your midpoint. Finally, we went over the Pythagorean theorem. Always remember a squared plus b squared equals c squared. C will always be across from the right angle, and it is also your hypotenuse, which is the longer leg.
Nicely done, scholars. I love you so much. Keep up your hard work. I've been Miss Atkin.
And I've been Lisa.
And we'll see you next time.